Hello students, now in class 12th I told you about the formation of energy band in solids, and now I will take the classification of the substances on the basis of band theory. Types of solids. On the basis of band theory. You know that yesterday I told you that there are two kinds of bands. One is the conduction band and second is the valence band. In valence band there are the valence electrons, and between the conduction and the valence band there is a gap which is called the band gap or the forbidden energy gap. And the value of this forbidden energy gap depends upon the temperature and the bandwidth, and that is the nature of the solid. So now we have this is the forbidden energy gap, this is the conduction band, this is valence band, so this delta Eg let this is the energy EC and this is energy EV. Here we take the energy let EC equal to energy of conduction band, EV energy of and you know that we have taken this at the bottom and this at the top of the valence band. So the difference between these two, then forbidden energy gap, energy gap Eg is equal to EC minus EV. So mostly the electrons are here. These are the electrons in the valence band. Now conductors, number one, conductors. There is no forbidden energy gap due to partial overlapping of conduction and valence bands. Valence bands. So what happens that suppose this is and then at this point we are getting this is the overlapping area. This is your valence band and this is conduction band. Conduction band. This is overlapping. 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 So it means that in these conductors the forbidden energy gap therefore Eg equal to 0. So sum of the electrons, sum of electrons from valence band go to conduction band. Conduction band where they give electrical conductivity. Electrical conductivity. So mostly the electrons are in conduction band. So this is what that then in case of conductors there is no energy gap or energy gap is 0. Then there is because this overlapping of the conduction band and the valence band, some of the electrons are here. These are the electrons that you can see. When the electrons goes from valence band to conduction band, then there is a vacancy which is created in the valence band, and this vacancy is soon filled by other electrons which are present in the valence band. Now second is insulators. Insulators. There is large forbidden energy gap in insulators. So no electron is found in conduction band. Showing no electrical conductivity. Showing no electrical conductivity. The forbidden energy gap Eg, this is greater than 3 electron volt. So this Eg greater than 3 electron volt but less than 7 electron volt. This is the limit for the insulators. And we can have that for diamond. Eg equal to 7 electron volt. This is the maximum energy gap. So since the energy gap is very high, so no electron can go from valence band to conduction band. The electrons from valence band do not reach to conduction band because they have insufficient energy to cross the band gap. So it means that their electrical conductivity is 0. This is why resistance of insulators is extremely large. So they do not exhibit the electrical conductivity. So here we have, suppose this is and you can have, this is suppose conduction band, and this is suppose valence band, then this is the forbidden energy gap Eg, which is greater than 3 electron volt. So thus the energy gap is very large. So the electron cannot cross this energy gap and they cannot reach in the conduction band. So this is why that there is no electrical conductivity of these insulators. Now third is semiconductors. Semiconductors. The band gap in semiconductors is small, so that some electron from valence band go to conduction band, where they show electrical conductivity. Here the band gap Eg is less than 3 electron volt. For example, silicon, this is 1.12 electron volt, germanium, this is 0.72 electron volt. For example, for silicon, Eg equal to 1.12 electron volt, and for germanium this Eg equal to 0.72 electron volt. This may be also less than to this one. So this energy gap depends upon the nature of the substance. So because the energy gap is very less, so at room temperature some of the electrons from the valence band goes to the conduction band. Now here we can have that this is, suppose here this conduction band, and here this is valence band, and this energy gap is small. This is Eg less than 3 electron volt. So because of a small gap, some of the electron from the valence band goes to the conduction band, and there they exhibit the electrical conductivity. So the electrical conductivity of these semiconductors is less than the conductors but more than the insulators. When the electron leap to the valence band, then there is again a vacancy which is created, and this vacancy is again the positive, which are the holes. So in semiconductors there are the electrons in the conduction band and the holes in the valence band. in semiconductors, the electrons are in conduction band and corresponding holes are in valence band. And both the electron and holes are responsible for the electrical conductivity. Both electron and hole shows electrical conductivity. Electrical conductivity. So this is the types of solids on the basis of band theory. When there is no energy gap between the conduction and valence band, then this is the conductor, and when the energy gap is large enough, which is more than 3 electron volt, then this is the insulator, and when it is less than 3 electron volt, then it is the semiconductor. So thus on the basis of band theory, we can classify the solids into 3 categories. So you all like, share and subscribe this video. Thank you.